So we just wrapped up lecture and there were some great questions that came in on the first two diagrams. We didn't get to this third diagram, but I think it's a worthwhile problem to try tracing through and being sure you understand what's going on. So if you haven't tried doing this yourself, I would encourage you to pause the video here and work through this in the stack heap diagram and resume once you're ready to see the solution. All right, let's talk through it. So in this example, we're working with dictionaries and lists, and those are objects that are reference types that will live in our heap. So we have two areas of our program's memory that we're primarily concerned with: the call stack and the heap. The call stack is going to be where we keep track of our globals, and those are names such as the names of functions, the names of classes, things like that. And then when we start making function calls, such as this call to the function named main, we're going to set up new frames on our call stack to keep track of those function calls as local variables. And then on the heap, that's where our objects are going to live. And we'll also see that in a dynamic language like Python, we can assume that our function definitions and class definitions live there as well. So let's go ahead and set this problem up. And we're going to start with our globals frame. And our globals frame is technically, if we wanted to do this exactly the way that the system is doing this, when you see import lines, it actually introduces new names into our globals. But we're not going to worry about this in how we trace through this, because we're not going to know, well, how does Python actually implement a dictionary and a list. But if we wanted to be very pedantic, after importing dictionary and list, those would be names, right, that were stored on from typing, right? And we don't really know how from typing works or how to go look up that code. So we're not going to worry about diagramming that. But technically, when you import things, those names are entered into whatever frame you're importing in. So here, because we imported at the global frame, they would now be names that we would use in our we could use at the globals level and throughout the rest of this this file. Okay, so what our concerns really begin with this main function. So we have the definition of main, and main is stored in the heap. It's a function from lines 4 to 10. All right, and init is another function. So there's two functions defined in this program, and it's the function from lines 13 to 15. All right, so we've got our two function definitions established, and then, so we've read through this, Remember, when we read the definitions of functions, we're not actually calling them. We're just sort of, the computer's understanding this is the recipe for it, and we're keeping track of where the names of these functions are bound to in our program's code. And now we reach this line. We assume when we reach an if name is equal to main, that when we're tracing one of these in a diagram, we're going to assume that that is true. So we do call the main function, and that says, okay, well, main is the function on lines 4 to 10. It's this one up here. So Python has seen this function name before. It knows how to call it. And we're going to go ahead and set up a frame for the main function. It doesn't have any parameters to set up, and we're going to set up the return address. And the return address is the line that the function call occurs on. So the return address is line 19. Notice that this call to main occurred right here on line 19, even though the definition of this function was from 4 to 10, right? So this is what causes us, this function call causes us to jump up to this point. And we know that when we finish, we've got to go back to where this function call occurred, right? And that's what the return address is keeping track of. So we jump into main, and okay, well, we've got a counts dictionary being initialized, and it's assigned a empty dictionary, right? So these empty curly braces mean an empty dictionary. I want to point out that dictionary we could also construct with a dictionary constructor, which is the because it's a built-in type, and for reasons that are historical in Python, it uses the lowercase d, but you could have constructed an empty dictionary just like this, and just like we construct our objects using a constructor function. But this literal is setting up a new empty dictionary. So let's go ahead and set up this empty dictionary. When we set up a dictionary on the heap, we're going to keep track of the types of its keys and values. So we're going to say dictionary of key value is, or sorry, the key type is string, and the value type is integer. All right, so this is a dictionary that's going to map from strings to integers. and it's initially empty, right? It doesn't have any keys in it by default. We didn't use this syntax to establish any keys. Okay, on the next line, oh, I didn't actually finish this out. So we just evaluated the right-hand side of this assignment operator. Now we need to say, well, okay, we need to assign that to counts, right? Well, counts is going to be a local variable in main, and counts is going to be bound to this dictionary object, right? All right, so counts is bound to a dictionary object in the heap with no entries in it. And now what do we do? Well, we see on the right-hand side, so we've got this another initialization statement. We're saying words is going to be a variable whose type is a list of strings, and it's assigned initially this list of string literals, the, and but, right? So we've got to first, you always want to evaluate the right-hand side of your assignment statements first. So now we're going to set up an object that's a list of type string, and it's going to have 3 values in it. And we know if lists are values are indexed, or items are indexed by integers. You know what? Let me make this just a little bit smaller because I think I'm going to add keys to my dictionary. I need to make sure there's room to do that. So list is of type string, and it's got 3 entries in it, right? So we've just set up 3 string values in this list. Index 0 has the string the, index 1 has the string and index 2 has the string but, right? Great, so we've got our list object set up, and we know that after we establish this list object, it's going to be bound to words in the main frame. So I'm going to have a local variable named words in main, and it's going to be bound to this object, right? This list object. Great. All right, so let me just make sure I've got enough space here. So I'm just going to leave this empty for now. And dictionary just doesn't have any entries in it yet. We're going to be adding some in just a little bit. So we've fully established these 2 variables. We've completed these 2 lines of code. And remember, the processor is just going to move in order top to bottom until it reaches a function call or a loop or an if statement, and then those special moves apply. The special control flow distinctions apply. When we reach this call to init, we've reached a function call. So we need to say, okay, well, do we even know what this function is? And there's nothing named init in our main function. So we look in our globals function, and sure enough, we see that that's the function defined on lines 13 through 15. So we've seen this function before. And we look at that function and it says, okay, I've got 1 parameter. The first parameter is going to need a dictionary of string to ints. So we ask, well, okay, is the argument, which is counts, actually a dictionary of string to ints? And yes, counts was defined to be a dictionary of string to ints. And the second parameter, keys, is going to be a list of strings. And here the second argument to this call is words, and that's a list of strings. Okay, so this looks like a valid function call. So let's go ahead and set up this function frame. Okay? So the function frame is going to be named init. Its return address is going to be line 7 because that's where this function call occurred, right? So this is where the function call occurs. And now we need to set up the parameters. So our first parameter is named store, and our second parameter is named keys, right? So how do we establish these parameters? Well, store is being assigned whatever counts is, right? So store is being whatever assigned counts is. Counts is a reference to this dictionary from string to ints. So store is also going to be a reference to that dictionary, right? Same idea with words. So words is being assigned to the parameter named keys. So what is words? Well, words is a reference to this list of strings. So keys is also going to be a reference to that list of strings, right? And so now we've established our return address, we've established our parameters, we're ready to jump into this function, right? And so notice that store refers to the empty dictionary and keys to this list with 3 entries in it. Well, here we see a for in loop. And we know that with for in, we're going to move through, we're going to iterate through each and every item in whatever sequence we're processing. And so this sequence is the sequence of strings, the, and but, all right? So let's go ahead and in init, while this for loop is being processed, we're going to have a variable named word. And let me give myself a little bit more space here because we're going to store this string right here. So word is going to be assigned initially the string the, right? And so we go into line 15, And the reason why word is assigned v is because that's the very first, as we are moving this for loop, I'll use this little arrow to keep track of where we are in this. Now, this isn't a formal part of the diagram. We're just trying to keep track of what are we currently processing in this for loop, right? So currently our cursor is on the item the, so word is the, and now we're trying to break down this particular line. And here we're saying, okay, the value 0 is going to be assigned to, and on the left-hand side, we're saying store, which is this dictionary. And when we see this subscription notation or the square brackets, and we're thinking in terms of a dictionary, we're saying, okay, we're actually going to set up, is there anything currently stored at the key the, right? So word is the string the. So this is the same as saying store of the string the is assigned 0. Right? Well, no, this is empty dictionary. There's no key there already. So we're going to go ahead and add the key the and a value 0 associated with it. Right? So we've just introduced a new key value pair into our dictionary. All right. And we're done with that for loops, that iteration of it. So we go back and we say, okay, is there anything else in this list that we need to process? Yes. The and is the next string. So we have this word name that will be assigned and now we're once again saying store, the string word evaluates to the string and, right? So that would be store of and is assigned 0. Well, this dictionary doesn't have a key who's assigned and, so we're going to add a new key value pair here, and its value is going to be 0 as well, right? And the reason it's 0 is because that's what we're saying here. We're saying take 0 and assign it to whatever word we're adding to our dictionary. So you can kind of get the sense that this function is trying to initialize a dictionary named store with all of the keys that were given to us in this list. So we're not quite done yet. This for loop has one more item to process, and that's the string but. So word would be reassigned but in our init function call. And here store of, and then word, right? We look up what is word, it's the string but, is assigned 0 is what this line would evaluate to. So again, we haven't seen that string as a key before, so we're going to add that key here. So the string but is initially 0. All right, great. So we're done with this for loop. We've processed all of the items in that list, and we've reached the end of this init function call, so the return value would be none, right? So this function call is done. Where do we go back to? Well, we go back to line 7. Line 7 was where that function call was encountered. We're ready to continue on, all right? So this next line, let's break this down. And actually, I'm going to write this down below so that we can process this step by step. So counts of words index 1 is assigned at whatever current value plus equal to, right? So we increase whatever its current value is by 2. All right, when you see a complex expression like this, it helps to work your way out. So we know that the right-hand side of this is fully evaluated. It's 2, there's nothing more for us to do with the right-hand side. But the left-hand side is a little bit more nuanced, right? Well, okay, what is words index 1? All right, so what frame are we in? We're in the main frame. And words is a reference to this list of strings, and index 1 is the string and, right? So when this evaluates, we're saying counts of the string and is increased by 2, right? So that's what this evaluates to. Okay, well, where do we find counts of the string and? Well, counts in the main frame, we look in the main frame because that's where we're currently at. It's the lowest function in our stack that hasn't yet returned. And we look at it and we see counts is here. It's a dictionary, and we find the key and we're increasing its value by 2. Right? So this becomes 2. So we've said counts key and is increased by 2. Well, we've just updated our diagram to reflect that. Okay. So we've completely evaluated this line. And now you see an even wilder one, right? So this one is pretty contrived, but the intent is really to force us to break this down. All right, so let's work our way out. So what is words index 2? So words is here. Index 2 is the string but, all right? So the string but, right? And the next thing that we need to process, actually, let me write this just a little bit higher. String but and word counts. So now the question is, what is counts of the string but? Well, okay, we're still looking up in main, so we're trying to evaluate this expression, which is here. Counts of the string but is currently 0. So this would evaluate to 0. Okay. Now we're asking, well, what is words of index 0, right? So now the question is, what is words of index 0? So, okay, we're looking up words. We're in the main frame. We look up words index 0. That's the string the. Okay, so the string the. And we're saying counts of the string the is increased by 3. All right, so this expression here simplified in that way, right? And this is a contrived expression. This is pretty awful in terms of, I hope, and I would never encourage you to write something like this, but I think it's important to be able to read something like this because there are other places where you'll find similar things encountered. And it's worth knowing how something like this does break down. But here we're saying counts of the string the is increased by 3, right? We should have just written it like that if that's what we were actually trying to do. But this is an exercise in diagramming, right? So counts of the word the, counts is this dictionary, the word the key the is increased by 3. So the key the is assigned a value of 3. And that line has finally completed, right? So there are a lot of steps involved in finishing out that line. And now we print counts. So I would have an output column. This is our first bit of output. Typically, I would probably put this to the right of my heap if I were doing this on paper. But as long as we know where it is and it's clearly delineated, that's fine. And what is counts? Well, counts is this dictionary. And if we ask you to print a dictionary, if you were to do it in Python's the way Python would, that'd be totally fine. So what Python would print out is the curly brace, and then it would have the :3, comma, and :2, comma, and then I'm just going to write this down on the next line, even though this would all be one line. But :0. All right. So I would encourage you to try printing out a dictionary with these key values associated with it. There wouldn't really be this wrap here. This should have all been on one line, but that's how that would have printed. And then we reach the end of the main function call. We have a return value of none, and we return back to line 19. After that, our program's completed. There's nothing else for us to do. So this is a complete walkthrough of this code listing. And the couple of important concepts to take away here are primarily how we work with dictionaries and lists on the heap when we start working with these types of objects. And we know that dictionaries, the key type is whatever we want it to be, as long as it's immutable. And then the value type is whatever we specify it as in the type that we use for declaring a dictionary, right? And then with lists, each of the indices is always going to be an integer starting from 0 and counting up. And the value types are what we specify in the square brackets of the list type, right? So we knew that those types were specified here. Then this exercise is sort of a little bit of a winding road or a challenge when thinking about how do we actually evaluate left-hand sides of assignment statements that are more complex. And so here we're changing keys in the counts dictionary, and the expression that we're using to figure out, well, what key is it that we're actually going to change is an expression, right? And this expression ultimately needs to evaluate to a string type. And again, in the example where it's words of 1, that we could have achieved the same thing with string of, with counts of string and, right? We could have written just hard-coded the string and there. But for the purposes of just getting some practice, thinking through how do we evaluate these expressions, and then these more complete statements, that was the emphasis of the latter part of this diagramming exercise. So great work on this and great work today. We'll have some more practice problems out for you soon. Otherwise, keep working on the current project.